This is problem 93 of Neetcode 150, network delay time. So let's read the problem. You are given a network of n directed nodes labeled from 1 to n. We're also going to be given times, and it's going to contain basically three values. So let's just go straight to the example. In times, we have, for example, the list containing 1, 2, and 1. We have another list containing 2, 3, and 1. We have another one containing 1, 4, and 4. And what these numbers means, the first number is basically going to be, as you can see here, so it's going to be the source node, so the node we're starting from. The second number is going to be the target node, and the third number is the time it takes to reach a node. So if you retake the first node 1, well, 1 will be the first value, 2 here will be the second value because it's the target node, and that 1 here along the edge is basically the time it takes to go from 1 to 2. What we basically want to do is to travel all these nodes in the less amount of time possible. So we want to see like how fast can the network travel through all the nodes. So if we just use our basic logic here, we're starting from 1, we can go to 2, or we can go to 4. Um, at, at 2, we can go to 3. At 4, we can also go to 3. So basically, there are a couple way to do, to travel all the nodes. Notice that we're going to be given a value k, and k is the node we have to start at. So we don't really have the choice to go somewhere else. And we're also given n, which is the number of nodes in the graph. So the shortest path here, or like the path that will allow us to go through all the nodes in the shortest amount of time possible, will be to start at R1, to go to R2, to go to R3, and to go to R4 for a grand total of 3 units of time. So the approach I will use in this tutorial to solve this problem is quite a naive approach. I will basically build a min heap, and what I will do in the min heap is that I will add the direct neighbors of the node that we are at. So if we start at 1, we are at node 1, and I will add its new two neighbors, so 2 and 4. And I will just take the top value of this min heap, and the min heap is going to give us the minimum value. So every time we have like a decision between two nodes, we're just going to take the path with the shortest uh, or like the distance that allow us to travel in the less amount of time possible. So let's go ahead and start coding this. Um, First, I will create a dictionary because I need to keep track of the nodes and its neighbors, and also the time it takes to go through its neighbors. So I can just call this the edges. And I will create a default dict for this. And of course, I want a list to store two values, so a tuple. And basically, I will go through all the values inside time. So I will say for, and now feel free to call this however you want, but I will say SN for source node, TN for target node, and T for time. So for all three inside times, what I will do is that in our dictionary edges, I will set the source node to be the key, and I will add to this key the values of the target node and the time. All right, so now we can actually go build our min heap, um, since we have basically a dictionary in which we can easily retrieve all the neighbors for each node. So I will create my min heap. And initially in my min heap, I'm gonna have a time 0, and I will have the node k, because k recall that it is the value of the node that we have to start with. So let's do it this way. Um, I want to make sure that I keep track of the nodes that I've already seen, because otherwise we could potentially enter an infinite loop. So I will call a scene uh, set. So every time we see a value, we're going to add this to scene. And I will create my time value, which is initially at 0. And now we're going to be willing to actually while loop through all the values inside min heap until there is a min heap. And what we're going to do is that we're just going to pop the top value, which will be the shortest time, right? And for this shortest time, we're going to go see all its neighbors, and we're going to take the shortest times for its neighbors as well. So, right, we're going to set something. Basically, let me just do this for now. This is going to be equal to eq dot epop, and you want to pop the min heap. So what are we going to retrieve from the the min heap? We're going to retrieve time basically, and we're also going to retrieve k, which is a node, like that. All right, so now we have a node and the time of the shortest distance, and we want to check if the node has not been seen yet. So if node not in seen, this is important. Well, in fact, if node in seen, we will just continue. Right, we're only going to do the steps below. So if we didn't continue, so we keep going inside this loop, we're going to add to scene the node, and we're also going to set the time to be equal to the time, because after this we're going to go see all its neighbors, and we're going to append to the total time that we have in our min heap the time of the shortest path that we have starting from a certain node. So after this, what I'm going to do is that I will say for I can call this tn, or so for tn, and also t in edges, but I actually call time above, so let me just call this t1, okay, which stands for the time in edges at this node. So inside the dictionary nodes, we're going to retrieve basically the target node or its neighbor nodes, or yeah, let me just say neighbor nodes and time 1. So for each of them, basically what we're going to do is that if that particular node, so if the neighbor has not been visited yet, we're basically gonna push it to the daemon heap. So I will say if nay not in scene, well, I will say eq dot epush, and inside my epush, I need to specify the tree that we want to push in. In our case, it's min heap, and then I need to pass the node. So inside our node, I will actually pass the time. So the time will be t1 plus also time here, right? Because we want to keep track of the entire time that that it will take basically to go through this node. And after this, what I want to pass, it's the neighbor as the node. So we're going to go see this function again, because we're adding this to the min heap. So we're going to go inside this while loop again, unless there's nothing to push. And we're going to go take basically the top value that we just added, which is the shortest path. And in this, we're going to retrieve the time and the node. The time is basically going to be the, the total time that we previously had plus plus the new time of the new nodes that we just retrieved. So this is what we are embedding here. And now we're going to pass basically the neighbor nodes of the one that we just picked out of the min heap. And that's actually it. So now we can basically return t. But just to avoid getting an error for the edge case, I'm going to return tree only if we've seen all the nodes. So if the length of scene is equal to n, notice that n is the value we're given that tells us how many nodes we have. Otherwise, we want to return -1, which is the default value that we're going to receive if it is impossible for all the nodes to get the signal. So this is the entire code. Let's submit this. And it works. Awesome. So I hope you learned from this video, and I hope to see you in the next one.